So this is the setup. It's 2.5-inch bars through the chuck. And it's protruding out about 4 inches or so. The part length 4.5 inches. And it's being supported on the end with a tail center, live tail stock set up in the lower turret. And these holes have been milled out, circle milled. And I don't know if you can see that, but our finished dimension on these is going to be 1.002. We're at just about 20 thousandths under, leaving 10 thousandths per side. And then finished dimension on this hole right here is going to be 814 thousandths. And we're a little over 20,000 stock allowance. Focus in on that. But yeah, we're leaving about 9 thousandths per side on that smaller hole. So just here's a quick shot of the program. You can see the boron bar right there. And it's set to run at 750 surface feet, 3 thousandths inches per rev. And we have flood coolant and just regular coolant pressure. Alright, so here we are. The boron head is called up, spinning at about 2860 RPM, 750 surface feet. I don't know how well the video is going to show up when the coolant starts up, but we'll give it a go. Alright, here it goes. Yeah, it sounds like it's chattering pretty bad. I'm going to stop it after this pass. Yeah, so it's pretty bad chatter, and it's probably the worst chatter I've seen. It literally is like a knurl in there. I don't know how well it's going to show up in the camera. Oh yeah. So that was an 8,000 CF in a 4215 grade, I believe. Yeah, this guy right here. Oh, I'm sorry, 4225 grade. With an 8 thousandths radius. And I can't remember the exact number of the bar, but it was the, I think the dash 17 bar. No, the dash 20 bar. It was enough to get the 1-inch, 1.002 diameter. Figured I would come in and just measure the bore of that shattered hole, just to make sure that, you know, the boron bar was set correctly. And 1.002, so you know, just to verify that the boron bar wasn't way off and that it wasn't actually taking off the 10,000 stock allowance. And again, the setup of the spool is the C4 boring head with a C6 to a C4, you know, reduction coupling. Pretty much, you need to have at least that, you know, extent so that the turret can clear the chuck. I don't think it's a long enough requirement to, you know, require some dampening extension or anything like that. All right, so what we're going to do now is we'll try to bore the 814,000th hole. Again, we saw the parameters previously. 750 surface feet, 3,000 IPR, and we've left 10,000 per side stock allowance. Same type setup as far as work holding, the tool holding, the C4, C6 reduction coupling with the Sandvik fine boring head, and this is the dash 17 boring bar to get us down into the diameter range to make the 814 hole. This test is going to be done with the MF geometry insert in the 1125 grade. So let's see if this fares any better. Turn the coolant on and let her eat. Yeah, I hear some chatter pretty much halfway down. What you hear right there is probably from another machine over running on the other aisle. And retract. And let's see what we got. It actually fared a lot better. There's still chatter in there. I don't know if I'll be able to pick it up. And yeah, there you go. You can see there's still chatter there. I'll run a profilometer on it here once I get the part off. But from the looks of it, and the feel of it, I mean, that's probably not even a 63. That's probably up in the 80 range if I had to guess. So still kind of striking out with the getting a boring head to work well for this application. We've had some good luck in 17.4 stainless, doing a similar hole, except for we were using the 824. I think it's 824. Really, more of a boring head where it doesn't have a bar sticking out of it. It's just more of a, a head with that little 1.2 size insert, 5/32 IC hanging off the side of it. But it won't go down. I don't believe it'll go down small enough to do. Well, certainly wouldn't go down to get the 814 hole. And I'm not sure if it'll go down to get the 1.002 hole. So that's really not much of an option at this point. Since the MF insert did a noticeably better job resisting the chatter right off the bat with those parameters on that smaller hole, I still have one hole that hasn't been finished yet, so I decided to take that MF insert and put it in the other boring head, or actually put it in the second insert. But basically put the MF insert in the larger boring head. And cut the surface footage down to 400. You kind of do a drastic change to see if going in that direction makes a difference. And I bumped the feed rate down to 2,000 inches per rev. Don't have a lot of parts left here to test, a lot of holes, so trying to make some educated thoughts on just some changes to see what direction I might want to go in. Better or worse. We'll give it a try. Here comes a little bit of chatter. I can hear the harmonics. It's at 1500 RPMs. Speeding it up a little bit. Nah, that's from the other machine. Alright, we're through the hole. I sped it up about halfway down to a 30% increase. Maybe I should have tried slowing it down, but let's take a look. From this standpoint, it looks pretty clean up at the top. I gotta get it in this out of the machine and in some better light to really see what that finish looks like. I'm having a hard time focusing in on it. And it looks like where I sped it up down at the bottom, it didn't like that. It started chattering at 30% higher than 40 surface footage, so I don't know, I'm curious to get that out and measure that. I'll do that. Alright, so we're going to measure the surface finish of that third hole that we did with the MF insert. 10 thousandths stock allowance per side of the hole, 2 thousandths IPR, and 350 surface speed. Yeah. And so it's measuring 27, which is good. I'd like to see it around 20, just to allow for a little bit of tool wear, and as things go on, you know, it always starts to creep a little bit, and you don't want any to go out of spec. I measured the third hole down here at the bottom just for grins, and it was like 150 RA. The chatter was a lot worse than I thought it was. Actually, I think I had. Did I try? No, I didn't. No, I thought I might have rerun it just to see if I could get a good part, but I think I wanted to see what it was like right off the machine in that finished state. And then we had a pretty bad chatter on the exit. And that was just from bumping the surface footage up 30% from the 400. So it looks like that might be onto something. I mean, it looks good now, you know. Of course, we're out of parts at this point. We run them all with an end mill. I'm going to run one more, and I'm going to set everything at 350 and 2 thousandths IPR, leave the 10 thou depth of cut, and just see if it makes a good part, consistent part, no chatter bands. At least giving some hope that this might be a process we can start, you know, a starting point for if we run these parts, or when we run these parts again, or another part that has similar. But looks like the MF insert geometry with that what is it, 1125 grade may have may have been the closest thing to being on the right track. So we set up and ran one more part with the MF insert. Check which one that was in the grade. The MF 1125, and they look visually a lot better. I'm going to do a quick measurement on it. one, 814.7. It's right on the high, but it's in. The finish looks really good. I don't see any chatter, at least in here in the machine. So I'm going to pull the part out and take it over the profilometer. So I have the part set up here on the profilometer. When I got it out of the machine, the boards didn't look quite as perfect as they did under the light inside the machine. When I got it out into the fluorescent lights, it's slightly torn, but passable. I still didn't see any real chatter. I don't know how this would run over the course of time with these settings. And again, these settings were 350 surface feet. I changed the feed to 0.0018 IPR, and I'll check the surface finish. So 21 there. Try and do this with one hand. So certainly within the 32 RA spec. I don't know why all the other inserts, the PF and the LK, giving me such grief. Then again, I mean, the LK seemed to run all right in the beginning of the program. I mean, at the beginning of the job, and then they seem to deteriorate quickly. I'm out of material. The job is done. This is the last part that I had to do. So I'll take some notes, and the next run comes up, I'll use it as a starting point. Maybe we can make the MF work. It's certainly, at this point, certainly a nicer, more consistent round hole than the end mill that we were using. You know, circle milling it was given us. So we'll just try that next time. See what we can get with future runs.